We need to practice balancing redox reactions because it's not hard. They're not hard to do, but you do have to practice it in order to get the hang of it. So we've got a couple, I think we have 3 that we're going to practice. And these are all in acidic solution. We are going to learn what to do in basic solution, but we're learning the acidic solution part first. So we're going to go through all the steps again in order. The very first step, divide into 2 half reactions. So we're going to pick one of our reactants. That's going to be one of our half reactions, Fe2+, and our other reactant, Cr2O7 dichromate. That's our other half reaction. And now we have to, what I'm going to do is leave quite a bit of space because we're just going to balance into these reactions. We're not going to keep rewriting them. So now we have to decide, Fe3+, which reaction makes more sense to have the Fe3+ in it? Are we going to take chromium and oxygen and just magically create iron out of nowhere? No, that doesn't make any sense. Keep the iron with the iron and keep the chromium with the chromium. Just doing what makes sense here. So that's step 1. Divide into 2 half reactions. Step 2, we're going to balance all of the atoms except hydrogen and oxygen. So for half reaction number 1, 1 iron on the left, 1 iron on the right, that's good. For half reaction number 2, 2 chromiums on the left, only 1 chromium on the right. So we're going to put a coefficient in front of that, Cr2+. Now the chromiums are balanced. The next thing we balance is oxygen, and we do that by adding water. Half reaction number 1, no oxygen. Half reaction number 2, 7 oxygen on the left, so we need 7 oxygen on the right. And we're going to do that by putting 7 water molecules on the right-hand side. So now our oxygen are balanced. Next thing, balance hydrogens by adding H+. Half reaction number 1, no hydrogens at all. Half reaction number 2, we have 7 times 2, we have 14 hydrogens on the right-hand side. So that means that we need to have 14 H+ on the left-hand side so that our hydrogens are balanced. All right, and then the next thing you have in your notes, if you're following along with your notes, we have, if the solution is basic, what are we going to do? Well, we're not dealing with a basic solution yet, so ignore that. The next thing that we're going to do, our next step, is to charge balance by adding electrons. In order to charge balance, we're going to look at the total charge on the left side of reaction 1. The total charge is a +2. And then on the right side, the total charge is a +3. So we're going to be comparing +2 to a +3. We're charge balancing by adding electrons, which means we need to pick the higher charge and we need to bring it down so that it matches the lower charge. So our high charge is a +3. We need to bring it down to a +2. We're going to do that by adding 1 electron. So now the charge on the right side is a +2, so it's charge balanced. For our half reaction number 2, the left side, that's got a total charge. We're adding everything up. I've got a -2 and a +14. This is a total charge of +12. And the right side has a total charge of 2 times +3. The right side has a total charge of +6. So now we're comparing +12 to a +6. We're looking for the higher of the 2, and we want to take that higher charge and bring it down. We want to bring that charge down to a +6, and we're going to do that by adding 6 electrons to the left side. Things are getting real messy. So our next goal is to multiply the half reactions as needed so that each half reaction has the same number of electrons. When we combine these half reactions together, our goal is to be able to cross off and eliminate the electrons, which means we want to have the same number on the left as we have on the right. So we have 6 electrons on the left side of half reaction number 2, 1 electron on the right side of half reaction number 1. So that means we want to take everything in half reaction number 1, we want to multiply everything by 6. So we can just actually fill that in. 6 Fe2 plus, 6 Fe3 plus, and 6 electrons. So now we have the same number of electrons on the left and the right side, and we're ready to combine these two reactions together. 6 Fe2 plus Cr2O7 2 minus plus 14 H plus 6 electrons. Those are all of my reactants. And now for my products, 6 Fe3 plus, 6 electrons, 2 Cr3 plus, and 7 H2O. Our last goal is to simplify, find anything on the left-hand side that's identical on the right-hand side. Fe2 plus is not the same thing as Fe3 plus. Those are not identical. They cannot be eliminated. Cr2O7 is only present on the left side. It's nowhere on the right. H plus is only on the left. It's nowhere on the right. So the only thing that we can cross off and simplify are the 6 electrons. And again, you always need to be able to cross your electrons out. If you can't, then you've done something wrong. You need to go back and double check. And if you want, you can check your work here. This beautiful reaction is not only going to be mass balanced, meaning same number of atoms on each side, but it's also going to be charge balanced, same charge on the left side and the right side. It's fantastic. Let's do another one. Here's another half reaction that we're balancing, again in acidic solution. So start by setting up your half reactions. I think I called that a half reaction, redox reaction. It's not a half reaction. So CH3OH is one of our reactants. Ce4 plus is our other reactant. So those are 2 half reactions started. CO2, where does it make sense to put CO2? It makes sense to put CO2 with the first half reaction because the first half reaction has carbon and oxygen. Second half reaction does not have either one of those things. And where does it make sense to put the Ce3 plus? It makes sense to put it with the Ce4 plus. So there's our half reactions. Now we need to balance all of our atoms except for hydrogen and oxygen. So for half reaction number 1, carbon, 1 on the left, 1 on the right, looks good. Half reaction number 2, Ce, 1 on the left, 1 on the right, looks good. Now we balance our water. In half reaction number 1, we balance oxygen using water. 1 oxygen on the left, 2 oxygen on the right. So we need 1 more oxygen on the left, and we're going to do that by adding a water molecule to the left. Half reaction number 2 has no oxygens. Now we're going to balance our hydrogens. We have 1, 2, 3, 4, 5, 6 hydrogens on the left, so we need to add 6 hydrogens as H plus on the right. And half reaction number 2 doesn't need this at all. Then the next thing that we're going to do is charge balance. What's the charge on the left-hand side of reaction number 1? It's neutral. What's the charge on the right-hand side of reaction number 1? It's a 6 plus. So we are comparing 0 versus a 6 plus. We need to pick the bigger number and we need to bring it down to match the smaller number. We need to bring 6 plus down to a 0. We're going to do that by adding 6 electrons. Now we're going to do the same thing for reaction number 2. Left side is a 4 plus, right side is a 3 plus. 4 plus is the bigger number. We need to bring it down to match 3 plus. We need to bring it down by 1 so that it matches 3 plus. Next thing we want to do is look at these two half reactions and match up the number of electrons in each half reaction. We have six electrons in the first half reaction and only 1 in half reaction number 2. So we want to multiply every single coefficient by 6. So now we have the same number of electrons in both half reactions. Put it all together, we get CH3OH plus H2O plus 6Ce4 plus 6 electrons makes CO2 plus 6H plus 6 electrons plus 6 Ce3 plus. Cross off everything that's on the left side and also on the right side, and there you go. Now for the crossing off part, you can actually do crossing off before you combine the two half reactions together. You can be comparing left sides to right sides before the combination, and that might save you a little bit of time. If you want to do that, you can totally do that. We're going to practice one more, and then we're going to learn about what to do with basic solutions. So here's our last practice redox reaction. Start by putting the half reactions together. So we have PO3, 3 minus, that's one reactant, and we have MnO4 minus, that's our other one. And now we're going to match our products up. We're going to put PO4, 3 minus with reaction number 1 and MnO2 with reaction number 2. So there we have the half reactions divided. Now we want to balance the phosphorus in reaction number 1, looks good. And the manganese, Mn, in reaction number 2, that looks good. Now let's balance our oxygen. We have 3 in reaction number 1. We have 3 on the left and 4 on the right, so we need to add a water molecule to the left side. Now we have 4 on the left, 4 on the right. And for half reaction number 2, we have 4 oxygen on the left and only 2 on the right, so that means we need 2 H2O on the right. And now we need to balance our hydrogen. 2 hydrogen on the left of reaction number 1, so we need 2 H plus on the right. And for reaction number 2, we have 1, 2, 3, 4 hydrogen on the right side, so we need 4 H plus on the left. Now we're ready to charge balance. This is the tricky part. We're going to start with half reaction number 1. Total charge on the left-hand side is a -3. And total charge on the right-hand side is a -3 plus 2, so that's a -1. Which one of these is bigger? Ooh, we got to really be thinking about math here. -3 versus -1. The -1 is bigger, so we need to bring it down to a -3. We're going to do that by adding 2 electrons to the right. Let's do the same thing for reaction number 2. Left side total charge is a -1 plus 4. That's a 3 plus total charge on the left. And on the right side, our total charge is 0. The +3 is the larger charge. We need to bring it down to a 0. We're going to do that by adding 3 electrons. Our last goal is to make sure that each half reaction has the same number of electrons, 2 in reaction number 1 versus 3 in reaction number 2. So reaction number 1 needs to get multiplied by 3, and reaction number 2 needs to get multiplied by 2. That's like, what's the math term for that? Least common multiple, something like that. 6 electrons is the smallest number that we can do here for the to make these have the same number of electrons. So what I'm going to do is change the coefficient of everything in half reaction number 1. We're multiplying all of them by a 3. That makes that a 6. That makes that a 6 as well. And for the half reaction number 2, same thing. I'm multiplying everything by 2. 4 times 2 is 8. 3 times 2 is 6. 1 times 2 is 2. 2 times 2 is 4. It's such a sloppy mess. Now we're going to put the whole thing together. 3 PO3 3 minus plus 3 H2O. plus 2 MnO4 minus plus 8 H plus 6 electrons. That's a lot of reactants. And our products, 3 PO4 3 minus plus 6 H plus 6 electrons plus 2 MnO2 plus 4 H2O. Kind of ran out of room there. Now I want to try to cancel. 3 PO3 3 minus does not exist on the right. 3 H2O. We also have water on the right. We have 3 waters on the left and 4 waters on the right. What we have in common, what the left side and the right side have in common, is 3 water molecules. So we can't cancel water completely, but we can cancel 3 water molecules from the left, and we can cancel 3 water molecules from the right. So the right side is going to be left with just 1. 2 MnO4, we do not have any MnO4 over on the right-hand side. 8 H plus, we have 6 H pluses on the right-hand side. So we can cancel 6 H pluses from each side of the equation. That's going to leave our left side with only 2. And then electrons, remember, those should always cancel. Again, it's messy. Let's rewrite it to make it look pretty. 3 PO3 3 minus plus 2 MnO4 minus plus 2H plus makes 3 PO4 3 minus 2 MnO2 and H2O. Now, one last thing we could do when we're in the middle of balancing a redox reaction, while we still have it divided into 2 half reactions, we are able to classify very easily. This is a great time to classify the half reactions as oxidations or reductions. Remembering oil rig, oxidation is loss of electrons, reduction is gain of electrons. In the oxidation reaction, electrons are being lost, meaning that they are being produced. They are products of the reaction. So in the first half reaction, because electrons are on the right-hand side, that's an oxidation reaction. Reduction is when we are gaining or adding electrons. So they're going to be on the left-hand side, or the reactant side.